All right. Hi, guys. It's Skylar, Data Ambassador. I hope you guys all had a great break, and I hope the midterm wasn't too bad. Today we're going to get into guided learning activity number 9. Um, and it's going to focus on parameter estimation and confidence intervals. And let's open the notebook. All right. So guided learning activity 9, parameter estimation. Going to start out by initializing the order. Okay. So learning objectives in this GLA. We got number 1, outline the process of estimating a parameter using a bootstrap confidence interval. So yeah, we did a little bit of that in class this week. Bootstrapping is when you resample, take a random sample multiple times from the same data with replacement to simulate kind of a variation in the data. Number 2, explore various topics in finance and stock portfolio management. So our case study today is going to be centered around the stock market, which brings us to 3, access stock market data from Yahoo Finance using the Y-Finance library. Then we're going to generate a bootstrap confidence interval for various parameters. And we're going to, of course, interpret the confidence intervals, which is not to be forgotten, and probably the most important part there, because without that, the rest of the work is kind of meaningless. So, going to configure the notebook, and moving on here. So, parameters versus statistics. A parameter is a measurement of a population, of the population. From a philosophical perspective, we consider the parameter to be a fixed value. So yeah, in math and in this case, what we're doing is we're considering the parameter to be some fixed value that is unknown, and we're trying to estimate it. Considering a population that changes, kind of like a dynamic parameter, I guess, that's always changing is more realistic. But since we're estimating, we're going to assume it's a fixed value to make that process a bit smoother. And then a statistic is a measurement of a sample, such as like sample mean, standard deviation, max. And the values of the statistic will vary with the samples. Random samples give random statistics. Our goal is to estimate a parameter using a random sample, data from a random sample, or statistic. We're estimating a parameter using a statistic that we are generating from random sample data. So now we got a more visual depiction of this process. So basically the initial question, right, is we're trying to figure out this population parameter. So what is the value of some parameter for a given population? We don't know. Usually it's I mean, it's like, yeah, in theory, it's really impossible to know because you need every single bit of data that exists from the population, which is not really realistic most of the time. But we can estimate, right? So the next step is, do we have all the related data on the population? Yes, you can calculate the parameter. Pretty unlikely that that occurs. So most of the time it's going to be no, we do not. I mean, also it depends on the population, right? If it's a small population, a specific population, yeah, maybe you do have all the data and you can calculate it. But most of the time, you're going to be trying to calculate the population is going to be a much bigger uh, group of data, group of people, or whatever the data is relating to. So yeah, so it's going to be tough to get all that. So we're going to generate a random sample from the population. The keyword is random there. And then we're going to calculate a statistic based on basically whatever the parameter we're trying to calculate. We're going to have a kind of related or related statistic to that. So if we're trying to estimate the parameter mean, we're going to get the random the sample mean. Store the statistic value. So that's going to be one statistic, and then we're going to resample many times, kind of this loop, calculating that same statistic. This is kind of where we use that for loop. And we're going to keep adding that statistic value for each random sample to the kind of the collection of values there. And that's going to create a distribution of all the sample statistics. So generate a distribution, we can graph that out, see how it looks. And then we're going to use the center and spread of the distribution to estimate the parameter. So the center and spread, that is, well, it can be multiple things, but typically it would be the mean or the median for the center, and then the spread is going to be the standard deviation, which is, yeah, it's a measure of how spread out the data is on average. Okay, so yeah, that's the process. Very important that we kind of internalize this and kind of understand the logic of why we're doing this. You know, why most of the time we can't just collect all the data from a population. And so hence why we need this random sample and even bootstrap sample in some situations. So this will be up here. It's a good reference. If you do need to come back and look at it, you can do that at any time as well. So that brings us to task 1. In the parameter estimation process outlined above, list some pros and cons of resampling from the original random sample from the population. So basically, pros and cons of bootstrapping, because you're resampling from the same data. So got pros and cons. So some pros about doing that is it's easier in that it's more efficient, let's say, in that it's less costly, because collecting data, it does cost either money or time, or most of the time both, right? Less costly in terms of money, time. So that's why the bootstrapping is nice, because you're using the same random sample over and over. So that's the main reason people do it, is it's advantageous, in terms of money and time. But it's also, the reasons it's good is it can simulate variation across sample data. And then for the cons, and I guess we can say useful when population data is inaccessible and funds are low. So the cons, and it's more like an asterisk on the pros, is everything relies on the initial sample, right? Because we're just resampling from that same sample. So if the initial sample is biased or too small, it might not be representative of the population, and thus the bootstrapping, I'll put slash resampling method, will misrepresent the true distribution of the statistic, which is kind of like saying the parameter, the parameter estimation will be off. Let's just say that. Okay, that's task one. Now, getting into the case study, we got stock data. So this is just a little background. We got a portfolio manager makes investment decisions for individuals or institutions. An investment strategy is a plan for how he's picking these stocks or these investments. It doesn't have to be a stock. It could be a fund. It could be an ETF. It could be lots of different collections of stocks. So portfolio manager might, for example, focus on large, stable companies, or you can, if they're more like risk averse and they're, yeah, more risk averse, and if they can also target fast growing tech startups, which is more high risk, high reward. Those stocks tend to be a little more volatile, so prone to like big jumps upward and downward. Invest in funds that track the entire stock market, like SPY, stuff like that, stuff that tracks the S&P, that tracks the NASDAQ, the Dow, etc. And then, or you can prioritize sustainable or ethical companies, which is something that can be done. That I don't know, I don't know how many portfolio managers really do that, at least at like the big institutions. But it's definitely, it's ethical, and it's something that hopefully we'll see a lot more of going forward. A portfolio manager can choose between strategies by estimating expected returns using historical data. So yeah, that is kind of the best way to speculate on future stock performance, is using the historical data. Obviously, it's not a perfect system, but that is kind of the best. Well, not the best, but it's one of the most common kind of ways to do that. And then returns for reference are profits of an investment. So how much stock goes up or down. Yahoo Finance. is kind of a big finance news hub and data platform that provides, all types of stuff, news, commentary, and then data. Uh, you can see all the different stocks. You can see all their charts on that website. And what we want to do is we're going to use this Y Finance library to pull some of that data into Python and then kind of manipulate it and make our own calculations. So kind of, yeah, just take that data and customize it a little bit to do a little more deep digging to inform our strategy, right? So run the command pip install Y Finance. And let's start with that. Okay. So there's a lot of processing going on. Okay, successfully installed. And then now we're going to import Y Finance as YF. Perfect. Okay, so now that we have that library installed, downloading stock data, a stock or share is a unit of ownership of a company. It's like equity in the company. Stocks are traded, well, public stocks are traded on stock exchanges, meaning that individuals, organizations can come together in a sort of marketplace to buy and sell stocks. The price of a stock varies over any given trading day. Yeah, it's never really level, especially the more it gets traded, the more kind of fluctuation there is. The Y Finance function download allows you to download stock information, and you can also specify the time period. Just like if you've ever looked at stock charts, you can kind of change between like one year, 1 month, year to date, 5 years, like total time ever since it became a stock and it had its IPO. What's nice about this is you can specify like specific days, which is kind of cool. So there's several parameters within this download function. There's the ticker, there are tickers. That's a string value. So the ticker is like essentially it's like the name of the company on the stock market. Usually it's like some sort of abbreviation for the company. It's usually on the shorter side, maybe like 4 to 6 letters. So yeah, it's referenced by its ticker, which is a unique alphabetic name that identifies the stock. So Apple is AAPL. Then you got the start, which is a string that specifies the start date in this format, year, month, date, and end, which is the same thing, but that's the end of the period. So task 3, using the YF download function, download Apple's daily stock information for the last 5 years as AAPL DF. And then we're going to use this table.fromDF function to convert that into a table, because it's gonna download the data as a data frame, which is a pandas data frame. Since we're not familiar with that here, we're going to convert that to a table, just using that function. So we got some kind of pre-written code here. So the tickers, we want AAPL. The start date, let's see. So today's April 11th. So we're gonna do end 2025. So we're gonna do 2020 0411. And yeah, it's all in string format. Oops. And then same thing here, but it's gonna be 2025 for the end. So that's today. And this is all kind of just pre-written. Yeah, and then here's the conversion from the data frames to the table. So we should be getting a table as the output here. And here we go. So we can see all this cool data. It's organized by date chronologically. So the 13th, the 14th, the 15th, I'm guessing the 11th and the 12th, 2020, that was probably a weekend, which is why we're not seeing those. And then, yeah, you got the closing price for the day, the opening price, you got the high for the day and the low for the day, and the volume, which is how many times the stock was traded that day. Yeah, so I kind of just went through that, but so date, closing price, so what was the price when the stock market closed that day? Highest price of the day, lowest price of the day. What was the price when it opened? And then the total number of shares that changed hands or were traded for that day. So task 4 is we're going to do the same thing, but for Tesla. So kind of just inputting these 3 values here. So 2020 for 11. And I think I still have that copied. 2020, whoops, 2025. Awesome. Okay. Okay, great. Yeah. So now we have all the Tesla data here saved as TSLA. And scrolling down, now we're on to task 5. So for task 5, it says create a table called closings, which contains all the closing prices for Apple and Tesla stocks over the last 5 years. So the table should have the following 3 columns in the presented order. So it wants us to output one table, and we have the columns it's asking for are stuff that's present from the Apple table and the Tesla table, and then we have the date, which is a common value. So what do we do with this? How do we do that? We already know the method, a method of how to do this, and that's called the join function, right? So we can implement that here. First, we're gonna just clean up the initial tables, I should say. So AAPL, I'll just say reduced equals AAPL dot select, and then we're only going to select the date and let me just see, and the close column. All right, that's good. So yeah, we can just check, see how that looks. That looks good. So now we're going to do the same thing for Tesla. Reduced TSLA, same thing, select date and close. All right, now we have these. And now we're gonna do this closings table. And we're gonna do that by joining these two. Yeah, I guess it doesn't really matter which one we start with. Start with Apple, dot join, and I'm gonna just check the documentation here. Column label of column that's used to join. Okay, so that's gonna be date. Other. Yeah. And then the other table is TSLA reduced. And then let's see what that looks like. Oh, I should probably. Let's do. Yeah, I'm gonna just fix the labels here. So I'll do relabeled, close, three columns. Okay. AAPL relabeled, close, TSLA. That should fix. Okay. Awesome. So that looks right. So yeah, I just had to relabel those columns before we joined them, or you could do it after as well. To make sure, yeah, we know which one's which. So all good there. Choosing between investment strategies. So now you're putting yourself in the shoes of this portfolio manager. We're trying to decide between the following two strategies. Do you want to invest your client's money based on Apple? So you want to invest in Apple, buy Apple stock. Do you want to invest your money based on Tesla stock? So yeah, like I said before, it's like you're just speculating based on, in this case especially, you're speculating just based on the past data, specifically past 5 years. But yeah, you can use this historical data to inform your speculation. So task number 6, we're just going to run this cell, and it's going to show us a line plot, kind of a overlay line plot. Yeah, so that's always nice to get a little visualization, especially for like time related data. And the question is compare and contrast the trend of the closing stock prices over the time period. How does this graphic inform you of your choice? So Tesla's the yellow, Apple's the red, or sorry, the black. So yeah, these are two very stocks that are behaving very different, but yet they start pretty close together and they're ending somewhat close together as well. Um, so yeah, you can see Apple's just a very like steady climber. Like it almost looks like it's like almost it's not flat, but like it almost looks flat because it's so zoomed out. That's how like steady it's going up, and it's not as it's fluctuating a bit, but it's not as much. It's kind of yeah, just more of a steady climber. Whereas Tesla, it's a lot more kind of like herky jerky. There's some big peaks and some big valleys, right? And then obviously you can see right around the time Trump got elected, this just shot up, um, at least for a little bit. And yeah, so let's type all that out. How does this inform you? So the Apple stock is a steady riser and seems like a safe investment for decent long-term gains. Tesla stock is much more volatile with heavy fluctuations and hence higher risk. I'll say you might yeah, we'll just say that. And then I'll say, yeah, I'll just say both have risen over time, but Tesla was I'll just say owning Tesla was much more of a roller coaster ride. Yeah. So, yeah, I mean, pretty much it's Tesla is why is this not there we go. Tesla is you might be like I guess the gains were a little higher over time. Um, but it's high risk, high reward. Who knows how it's going to be going forward? Whereas Apple seems a little more easier to predict that it's probably just going to keep steadily rising. Also Tesla, you might be a bit more, like it's going to be a little stress inducing owning this, right? You might want to sell. You might be tempted into selling either after a big gain or even on the way down. You might want to cut your losses. So you never really know what you're going to get, right? It's just a wild ride. Um, but it can be rewarding as well. So it just depends what kind of investor you are. So now we're getting into daily returns. Simple return for a stock from one time period to the next is defined by subtracting the previous closing price from the current closing price and dividing by the previous closing price. So essentially you're taking the percent increase. Analyzing returns lets us focus on the relative changes in stock prices over time rather than being distracted by the fact that they have different price scales. So yeah, it kind of takes out the price of the stock, and you're just focusing on like the percentage gain or loss, which is that's what it comes down to. So task number 7, we're going to create a table called returns that contains the daily returns for Apple and Tesla stock and closings to show the trend in the returns for both stocks over the last 5 years. Yeah, so we're basically going to have a table with all the returns from day to day for each of these stocks. These are the 3 columns. Date, same as before, date, Apple, Tesla. And we got some notes here that are going to kind of help us fill out this code. So you have an array. If you use this indexing format with the 1 and then the semicolon, that's going to give you everything in the array except for the first item, right? Because the first item is index 0. So this is going to give you essentially 1 through the end of the array. And then similarly, this one's going to give you everything except the last item. Or sorry, yeah, everything except last item, because last item is also known as index -1. So it's going to be, there's a blank for the beginning essentially. So that's just means everything through this index, which is -1. or up until, I should say, this index. So anyway, that's going to help us, but let's get into this coding. So closings. Okay. Yeah, so it's breaking it down into steps here. It just wants us to select the column so that we have an array here of the closings. And that's not the right table. So closings dot column AAPL. That's going to give us an array of all the closings. And closings dot column TSLA right there. And now we're gonna get the returns. So how we're gonna do that? We have an array with all of these closing prices. And basically we want to have the difference between the next day closing price and the previous day, and then we're dividing that by the previous day, right? So how do we do that easily within an array? Is we can use that npdiff function, right? So we're gonna have npdiff Apple closings. So that should give us like the change in the closings between each two items in the array, right? So that's essentially like we're doing day minus previous day, but that's going to give us one less item in the array, right? Because you're taking the difference between each two, so you're going to result in an array of one less item. And we know we have to divide by the previous day closings, right? So this is where this array indexing logic is going to come in, is we're going to have that. We're going to divide by the AAPL closings. But we can't, those arrays are not going to be the same size, right? So this one's going to have one extra item. And so what we're going to do is we're going to use this indexing. And since we're only dividing by the previous day, we're not going to need that last item in the array for the last day, right? Because there's no day after that in this time period. So we're going to cut that day out. And now that's essentially creating an array of all the previous day closings that we need to divide by. And then we're going to do the same thing for Tesla. So we're just going to change this to TSLA and change this to TSLA. So now the returns table is we're going to have okay, yeah. So we're going to have just table. I'll just create a new table, I guess. Table dot with columns. So the first column is going to be date. And we're going to do, let's see. So we'll just take closings dot column date. So that's going to give us an array, but we also want to trim this down by 1, right? But so all the dates in the way we're going to reference all of these returns is by the date the date of the day that we're taking the return from, right? Not the previous day. So essentially, we're going to do the reverse of what we did up here. So we're going to skip the first date in the array because we don't have any previous data to make a return for that day. And we're going to use that as the date data. And then we're going to do APL. And we're going to use this this data we have right here that we just created, and TSLA, which same thing. We're going to use these arrays that we just created. Returns. Oh, yeah, this should be returns. So I think this should give us what we're looking for, and we have an error. Closings dot column. Oh, okay. I just forgot the parentheses here. All right. So this is what we're getting here. And it kind of just looks like a mess. But yeah, that's basically a plot of all the daily returns. So obviously there's a lot of fluctuation. You can't really see the Apple fluctuations that much because they're kind of hidden behind the Tesla ones. But yeah, so that's what you're gonna get. Yeah, that's one of the things about how we're calculating these returns is we're doing daily returns, which in my opinion, I think it might be more useful to calculate like returns on a bit longer of a basis. Since for one, it's easier to like conceptualize the return when it's a little bigger number. Um, so you're gonna get that for longer periods of time most of the time. And also, yeah, it's like most of the time you're not going to be investing on a daily basis unless you're like a day trader and you're like pumping and dumping and buying and selling really quickly, right? So this might be more useful for that. Um, but yeah. So yeah, you just something to keep in mind is like there's different ways to analyze this data by time period as well. Um, and yeah, for month to month, you might see a bit more of like a clear trend. So parameters, considering the graph and your own experience, you might have an opinion based on which stock to base the investments on. So yeah, or you might even have like an internal bias on which company you like better, um, or you believe in more. But data science involves the use of data to make decisions. So since the returns vary for both stocks over time, we want some kind of metric, some measurement to kind of assess the stock's performance. And in this case, an average return could be useful to capture the expected return. Also, standard deviation, which is kind of a measure of the volatility of the stock, kind of helps us capture the spread of the return values, which can also be uh, defined as like the risk essentially. So estimate at the average return and volatility of each stock. And we're going to use those estimates to make our strategic decision. Okay. So calculate the average return and volatility of Apple and Tesla stocks using the following assignments. Okay. So we're going to have four variables here, I guess. Apple, mean, return. We'll just write out the variables first. Apple mean deviation and TSLA mean deviation. Okay. So we already have all this data, which is in this return tables, right? Because that's the data we're going to be using. So I'm just going to print this returns table right here. And yeah, so now we see we have the columns. Sometimes it helps to visualize a bit. So we want the mean return for Apple, right? We know how to do that. We're going to use the returns table dot column APL. And we're actually going to take the mean of that array. Just like that. Oops. And then we're going to do the same thing for, okay, I'm gonna adjust the variable names. Yeah, because the auto grader wants a specific variable name. So have return, oops. And then we're gonna use volatility instead of mean deviation. All right, there we go. Okay, so NP mean, I guess I'm just gonna copy this. Go. Boom. Gonna do from the Tesla column this time. And copy that again. But this time we're gonna take these np.std, which is standard deviation. And we're gonna do that for Tesla as well. Okay, sweet. So now we have these 4 variables. Estimating the parameters. So now we're coming back to this idea of estimating the population parameter, whether that's the mean or the standard deviation or whatever it is. We only have access to historical data, so that's a sample. So simply using historical averages as fixed values falsely assumes the past fully represents the future. The past data gives us a guess of future return and volatility, not a guarantee. Estimating helps account for uncertainty in using a sample to predict the future. So the sample average return and sample volatility could have turned out differently if we used a different time period or different opening prices. So to reduce bias in these estimates, we're going to try to create an interval estimate based on them. So confidence interval. And we're going to resample. And to do that, we're going to resample the returns from the past 5 years with this bootstrapping method that we learned. So AKA sampling with replacement from the same data. And that's going to give us, that's going to kind of simulate variability in the statistics, even though we're kind of just resampling from the same sample. Okay, so create a function bootstrap average returns with these 3 arguments, TBL, values label, n. So that's going to create n bootstraps resamples from the original sample of return data in the provided table. Where the return data is in the column, which is known as values label. Okay, and it's gonna return an array of these average returns based on the resamples. Okay. So I'll make an array called av return I'm gonna just make a blank array here. And I'm gonna do for rep in np.arrange n. Little for loop here. So what are we gonna do? We're gonna bootstrap resample. Okay. So I'll do resample column. Yeah. Okay. I'll do table.column. Values label. So that's the resample column. And then we're gonna do resample average returns, or resampled average returns. And that's gonna be, oh wait, no, because this has to be a table. Okay. Let me redo this. Okay. Resampled average returns. So we're gonna have this TBL. Okay, first of all, we're gonna resample this data, this table. We're gonna resample the rows of this data. So sample, so it is with replacement. That's the default, right? And yeah, so same amount as the regular table. And then we're gonna take that column, or we're gonna take the column called values label. So that's gonna give us an array of all these resampled returns. And then now I'm just gonna take the mean of all these. And then we're gonna add that to the av returns using this npappend function. Yeah, so resampled average returns, or whoops, that's gonna be what we're adding. Yeah, okay, cool. So this should give us an array with, this function should give us, essentially it will give us an array with n statistics of the averages that we got from bootstrapping. And we're gonna just return this array, return av returns. Okay. So this is a plot of resampled apple returns from 500 resamples. So you can see there's some variation here, and that was all simulated by this bootstrapping method. So it is pretty effective for doing that. And yeah, it still seems it's centered around 0.001. And yeah, a little bit of variation there. Similar, pretty symmetrical bell-shaped curve. And okay, there we go. So now we're moving on to task 10. Create a function, bootstrap volatilities, which is so basically the same thing, but we're calculating the volatilities. So what I'm going to do is I'm just going to copy paste this, but I'm going to change some of the variable names. So volatilities. Okay, I'll just do VOL here. Okay, so av volatilities and that looks, oh no, and then return av volatilities. Okay, so now this is gonna, what happened? Um, oh, my bad. I need to do np.std. And something's still wrong. Wait. It's n bootstrap resamples. Variable within the loop. Oh yeah, okay. I renamed it the wrong thing. There we go. Okay. Okay, perfect. Yeah, so here we have the distribution of these resampled standard deviations or volatilities. And yeah, similarly it's relatively normal looking distribution, maybe slightly skewed to the right, but pretty symmetric overall. And yeah, so this is for Apple. So yeah, it looks like our function is working there. Bootstrap sampling function. Okay, awesome. Okay, so now what we're going to do is we're going to incorporate the confidence interval. Um, confidence interval is an interval estimate for a parameter based on the sample data. So we're creating a confidence interval in this class by considering the range or a range in the middle of the resampled statistic, so in that distribution. And that range can be adjusted, it depends on the confidence level. So the standard level, yeah, usually the standard level is 95%. Sometimes you'll see 99. Yeah, it can be adjusted a bit, but 95 is pretty standard. The 95 confidence interval will include the middle 95% of the resample statistics. So the larger yeah, like a higher confidence level is going to lead to a wider interval because you're going to be, yeah, you're going to be more confident about the range. If you're going to be more confident about the range, it's going to be a bigger range essentially. Um, so task 11. So we're going to create 95% confidence interval estimates for Apple and Tesla's average returns using this bootstrap return function and 5,000 resamples. Okay. So AAPL returns. So we're going to use this bootstrap average returns table. So the table is going to be the returns table, AAPL, and N is 5,000. And then we're going to take the limits of the confidence interval. So we're going to use that percentile function. And the P, so the lower end is going to be 2.5. And we're going to take that from this AAPL returns array. And then for the upper return, it's going to be the 97.5 percentile. And we're going to do a similar thing for the Tesla returns, TSLA. And I'll copy this as well. There we go. A lot of copy pasting going on. And yeah, so this should give us this bootstrap confidence interval. So yeah, it says it should take about a minute to run. So let's give it a sec, do a little stretch break. Okay, great. So here, wait, okay, I was like, where's the Tesla one? Okay, okay, cool. So yeah, so you can see the bootstrap confidence interval for the average Apple return is between negative 0.00004 and this number, and Tesla's is between 0 and this number. And then yeah, you can notice that our intervals. No, you can yeah, you can see the intervals that we calculated. They include the average return values from task 8. Just a second, let me scroll back up. Well, let's just look. Okay, so it's so TSLA av return, APL av return. Yeah. Well, okay. Start with the Tesla one. So 0.002. You can see that's in this range right here. and AAPL return 0.001. So that's also going to be in this confidence interval range, which is as it's supposed to be. Okay, so now task 12, we're going to do the same thing, but we're going to do it for standard deviations. Okay, so yeah, same thing, except okay, so bootstrap average returns, no, bootstrap volatilities. Okay. Bootstrap volatilities and gonna be returns APL 5,000. Oops, 5,000. Percentile lower 2.5. APL volatilities. Just gonna add an I in there. And oops. Then change that to 97.5. Okay. And then change this. I'm going a little out of order here, but volatilities. Okay. And then, yeah. So then the Tesla one is going to be running the same function that we created, but we're just inputting a different column value, which is TSLA. Oops, two equal signs. That ain't good. Okay. We'll run that cell, give it a minute again. And then we'll do a little bit of interpretation afterwards to finish it off. Okay, so now we can see the Apple one coming in. And still running for the Tesla. What happened? No. Oops. I forgot to update the. There we go. All right. Give it another try. My bad, typo. All right. So we got these two ranges here. Just verify, or just to, yeah, we're gonna just look and check that our volatilities are in the range. So TSLA volatility 0.04, 0.040. So yeah, that's in that range. And same thing for AAPL volatility. So 0.0188. So that's, yeah, firmly in this range as well. Interpreting the confidence. So this is that was kind of a lot of number crunching. Now we're getting into the more um yeah, just practical interpretation here. Another thing to note is these these values, these like volatility values, and also the ones we calculated here, those are pretty much roughly in the center of the interval. And that makes sense because those are calculated from the original set, and then we're gonna resample. We're resampling from that same set to to generate this volatility or to generate this variation. Yeah, so just something to note there. Interpreting confidence. So yeah, we're assuming there's a true fixed value for the average return volatility of Apple and Tesla stocks, which is those are like that's the population parameters in this case. So the true parameters can't actually be calculated unless we had all the data from now until the end of time or until those companies go bankrupt or cease to exist. So that would be the full population, which is obviously that's impossible because we don't have these future values. So that might seem kind of contradictory or unhelpful in terms of an assumption, but it provides a philosophical foundation that allows us to estimate and make informed decisions based on partial data. So what does confidence mean? This is key of how to interpret a confidence interval. If we repeated this analysis many times using the same methods, 95% of the calculated intervals would contain the true value of the population parameter. So it's not a guarantee. It's a statement about the method, and how accurate the method is. So we did this, however many times, this same experiment, 95% of those would contain, of 95% of those experiments and confidence intervals would contain the true value for the population parameter. So average return confidence interval. This interval estimates the range for the true average daily return. So, for example, we got these two numbers. So you would say we're 95% confident that the true average return is between 0% and 0.2%. Same thing with this, estimates how much the return varies from day to day. So daily returns typically vary in this example by 1.7% to 1.9%. So yeah, 95% of confidence intervals constructed using this method would contain the true average return and the true average variation or volatility. So a narrow CI, a narrow confidence interval, implies more precise estimate, and a wide CI implies greater uncertainty. But of course, that's all relative. Because also the higher your confidence, the larger relatively, like the size of the interval will be relatively wider, the more you add confidence. And then vice versa. A smaller, if you're calculating, let's just say you're using the same data, and you're calculating a 90%, 95%, and a 99%. The 99% confidence interval is going to be the widest, whereas the 90% is going to be the most narrow because your confidence is a bit down, but the values are a bit more the value estimate is a bit more narrow. So it's kind of a trade-off, right? You're sacrificing confidence for precision in the estimate in the interval. And that's kind of why I think that's kind of why people settled on 95 because it's narrow, it's a high level of confidence, but it's not too narrow, or the interval's not too narrow, but the interval or sorry, the interval's not too wide, but the confidence is also not too low. So it's kind of a good middle ground there. Task 13, the final task, based on the estimates for average return of volatility, which strategy would you recommend? Yeah, for each stock, or I mean, which stock would you pick, I guess, or maybe you have a more complicated, a more complex strategy if you're more into, you're more familiar with investing and portfolio management and stuff like that. But so we can see, basically, we can see from these confidence intervals, Tesla has a higher average return, slightly higher upper confidence interval. Whereas it also has but yeah, I guess the trade-off is it has a much higher volatility confidence interval. Like these intervals don't even overlap, right? This is from 1.7% to 2%. And this is from 3.8% to 4.3%. So not even overlap, whereas the average returns do overlap. Tesla just has a bit higher of a ceiling on the confidence interval. So yeah, it's a bit similar to some of the observations maybe we concluded or we observed in the beginning based on the graphs, is just kind of, yeah, I mean there's no one right answer, right? But I'd say it just kind of guides us. But Tesla has a higher ceiling but is more risky. Apple is safer but with a lower estimated average daily return. You know, I think maybe the answer is also like you would kind of diversify and you'd invest in a little bit of both, right? So you have some of that upside, but you also have some stability in your portfolio, which is kind of, this is more like a finance topic, but yeah, you want a little bit of, you want to diversify your portfolio. You want high ceiling, but you also want like stability. So yeah, there's no right answer. It's just about using the data to inform our decision. So that was a good exercise in confidence intervals and bootstrapping. So for reflection, we explored the parameter estimation by distinguishing between parameters and statistics, including kind of learning or relearning, I guess, the bootstrapping process and why we do it. And then we learned to estimate the parameter using the bootstrap resampling. So yeah, after reviewing the conceptual process for parameter estimation, you apply the method in practical context using stock market data from Yahoo Finance. And we generated these bootstrap confidence intervals and interpreted the results. So yeah, that kind of brings us to the end. I hope you guys enjoyed this activity. I hope it was useful. I hope you learned a few things. And yeah, we'll see you guys next time.